Let me tell you what this is, this idea is first. The biology people are all going, oh yeah, alright. By the way, hands up biology people. Hands up. Yeah, good. A good sample of you. Thank you, hands down. Okay. A fair few of you then have heard this idea before, but most of you have not. So let's just underneath this line give you a really quick, like, one sentence definition for what this is, and then I'll show you the maths of it. Okay. So capture recapture is a technique for using samples. That's why it's in this idea here. Using samples to estimate a population size. So you can see why it belongs. Some people are like, why bio invading my maths class, okay? This is why it belongs here, because DS6 is about samples and population, okay? So how do you do this, or even why? When you're trying to work out a population size, if you can do something like a census, then that's great. You have really authoritative numbers, you check everyone exactly once, there's no double counting, there's no missing of people, so you can use those to get accurate numbers. However, that's not always possible, right? Particularly when you're dealing with populations, say for example, of, well I was just going to say animals, but whales is fine. Okay? So when you're dealing with animals, you can't just get them to line up in a nice neat line and make sure you don't double count them, and you make sure, is everyone here, are all the whales like present for roll call? You can't do that, okay? So here's the way we go about this, right? As the name suggests, you go into this population, you capture some of them, and then you mark them in some identifiable way, release them back into the wild, and then you recapture them and look at how many people have been tagged with that identifiable marker. So here's an example. Okay. So you're trying to work out how many fish are there in this lake. How many fish are there in this lake? But a lake is a mysterious place. It's dark, you can't see very far. The fish don't exactly stand up and say, hey, here I am, I'm number one. So what you do is you trawl your nets through, you capture 120 of them. You capture and you work out how many there are, and then you put a tag on all of them. Okay? So you've got 120 fish. They've all been labeled. Once you know which fish they are, because they've been tagged, and how many there are, you release them back into the lake. Okay? You then come back like a few days later or something like that, and you recapture, like you still pull that net through, okay? And you recapture 80. Right? So you've done the first stage, you captured and tagged, then you go back again. You might get the same number of fish, or you might get less. Maybe it's like a warm day or something like that, and there just aren't as many of them out anymore. So you recapture 80, and you notice that 6 of them have tags. Okay. Now, this is all the information we need. It's ingenious, actually, when you think about it. Okay. What have you just determined from this information? What you've shown is that you knew there are 120 tags floating around in the population. Okay? 120. Okay? Now, just as an example, suppose there were 12,000 fish. 12,000 fish in this population. What percentage of fish have been tagged? Exactly 1%, right? That's how many there would be. So therefore, when you recapture, you ought to expect about 1% of your fish have got tags on them, because 1% of them have been tagged. And the thing is, I don't know if there are 12,000, right? I don't know 120 out of 12,000, it might be 120 out of a million or something like that, right? So this number down here, the size of the population, I don't know what it is, so I'm going to use algebra, because this is what algebra is for. When you don't know what a number is, but you still want to work with it mathematically. This number here, whatever it ends up being, is the proportion of fish with tags. Please label that. That's really important that you understand why I'm putting this fraction into play, right? If n, I should actually label that too. That's the total population. If n were 12,000, like we mentioned, we know this was 1%, but I don't know what n is, so that's why I just give it a label. Now, this is what happens when you did the capture. Then we recapture, and we again look and we see, well, some of them have tags and some don't. Okay, what percentage has tags? Well, there were 6, but this time I knew the population that I was looking at had 80, right? This is this little subsection. So 6 out of 80 have the tags. And this should be identical. This is still the proportion of fish with tags and total fish, right? Does that make sense? So these proportions are equal on different days, at least we hope so. We'll talk about that later in a second. You don't want to put tags on your fish that make them, more likely or less likely to be eaten, because that will skew your population. And now all I need to do, all the way back to like AM1 and AM2, is I just need to solve for n. What will I do? I can cross multiply, that'll do. So 80 times 12 is like 8 times 12, sorry, 120. So that, I think, is 9,600, I think. And then if you multiply both sides by n, you get 6n over there. Okay. I want to make n the subject, so what will I do to both sides? I'll divide by 6, which I'm pretty sure leaves me with 1,600. Okay. Now, just pause for a moment. Do a sense check. Is this what you does this seem like a reasonable number? 1,600 fish in the lake?
No.
Well, I haven't told you anything about the size of the lake, but I'm just looking at these proportions. Does the number match? Well, this, 6 out of 80 is less than 10%, isn't it? It's less than 10%. 120 is less than 10%, so 1,600. And if you go ahead and you actually punch into your calculator, you get exactly the same percentage. Okay, does that make sense? So you see how sampling was used? I just took a sample, and then I resampled, and that gave me information about the whole population. So a really smart way to do things, okay?